Hi, good day, and welcome to my first video on transformations. All right, guys, now the transformations that we're going to be doing today, it's going to be using the matrices method. And this question, it's very popular in the CXC maths examination. So the first thing I need you to do is to pause the video and take down these 7 formulas. Just in case my handwriting is a little bit bad, this word here is reflection. This word is also reflection, 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 right? This is enlargement, and this one is clockwise rotation and anti-clockwise rotation. All right, so make sure and pause the video, and you see how I wrote my my formulas, my 7 formulas, very, very colorful. Please do the same. All right, make it look colorful, make it look big, carry it around and memorize these 7 equations. These 7 equations are not given on the formula sheet. All right, so I'm going to assume that you wrote it down. So I'm going to show you how to actually use this sheet. Now this sheet is pretty big, so I'll be moving it on and off the screen as required. Now here's what I need you to do. You need to work with me in this question. I drew up a graph here, right? And on the graph, you will see a triangle, right? So I need you to draw back this triangle, right? And just in case you can't make out the points, right? The point A is actually 1 minus 1, 1 minus 1. Point B is 1 minus 4. And C is 3 minus 4. All right, so pause the video and get a piece of graph paper and draw this with me. Believe me, watching me do this is not going to be the same as actually doing it with me, right? Okay, so the first question, the examiner will draw a shape on the graph, and then he may say, hey, this shape A, B, C, which is this black triangle here, he may ask you to reflect it in the x-axis. All right. Now remember, we're using a matrices method here. Now I know some of you all could actually do this using a little bit of common sense. If they ask you to reflect something in the x-axis, as you all know, this is the x-axis and this is the y-axis, all you have to do is pretend the x-axis is a mirror, and everything on this side will get reflected on the other side. So, but there's a quick idea of how it might look. It might look something like this. See, doesn't that look like a reflection on this side, and this is a mirror, so it gets flipped or reversed on the other side. Now the methods that we will be using will not be the common sense method. A lot of times in the exam you have to show actual calculations, and the only requirement to understanding this topic is that you have to be able to multiply matrices. So if you do not know how to multiply matrices, please go and look at those videos I made previously and then come back to this video, because I will not be reviewing on how to multiply matrices. All right, so let's see how to do this question. The examiner has asked us to reflect it in the x-axis. So I pull out my formulas and I look for this particular formula. Reflection in the x-axis. So here's how we apply this formula. We have to take this formula, which we memorize, and this formula is 1, 0, 0, minus 1. And what we need to do, I just wrote it here because I need the space here now. What we need to do is take this matrix and multiply it by point A, then multiply it by point B, then multiply it by point C. So this is how it will look. This is the matrix, and we are going to multiply it by point A. How much is point A? Right? That's going to write an A over it so you remember. Now you notice when you write a point, the x comes first and the y comes after. But when we have to take this point and multiply it by this, we have to write it vertical. 1 minus 1. The x goes on top and the y goes underneath. When we take this matrix and multiply it by this matrix, we will get two answers. The new answer, we will call it A prime. Well, some people call it A dash, but the real name is A prime. So, in case you, just to refresh your memory quickly, when you're taking a 2 by 2 matrix and you multiply by a 2 by 1 matrix, you get back a 2 by 1 matrix. So, like I said, I'm not going to review exactly how to multiply matrices, but when you multiply this by this, you will get 1, 1. The top will be x, the underneath will be y. So my new point, A prime, is actually 1, 1. So this is A prime here. And I'm going to put 1, 1. You notice when I plot my points, I actually put the x and y coordinates next to it. Guys, please make sure and do that in the exam. You will lose marks if you don't. Okay, it's really, really important. And if the point name is A prime, put A prime, put a little dash. So here's what we're going to do now. We're going to take the same matrix and multiply by point B. So your working will look like this now. You're going to multiply this matrix by B, and the answer will be B prime. Point B is 1 minus 4, so put 1 minus 4. The x goes on top, y goes underneath. When you multiply this by this, I believe you will get 1, 4. So my new point, B prime, is positive 1, positive 4. The B prime, 1, 4. And we're going to do the same thing for point C. All right, so point C. C is 3 minus 4. 3 minus 4. So this is point C, and the answer we will get will be C dash. Now you see how I'm writing point C over point C and C prime over the answer of C prime. When you're doing your working in the exam, please do it just like that. It makes it easy for the examiner to follow what you are doing. Anytime you're, I always tell my students this. Anytime you're doing a question and you're doing the working for the question, pretend that you are writing a textbook to be sold. If you are writing a textbook, or if you are buying a textbook, won't you want it to be perfectly explained and easy to understand? So remember that when you're doing your working. So when we multiply this by C, we will get 3, 4. The top is x, the underneath is y. 3, 4 is up here. This is C prime. 3, 4. And if we connect these points, we got the same answer that, well, we could have used. It's the same answer we could have gotten using common sense. But this is the actual working for it using the matrices method. All right. So if instead the examiner asks you to reflect A, B, C in the y-axis, if you would have used this formula instead, if it was a reflection in the y-axis, and it would have ended up on this side. Because if this is the y-axis, that means you're pretending the y-axis is a mirror. And if you are standing on this side of a mirror and you look at your reflection, it looks reversed, because in a mirror, your left hand looks like your right hand. Okay? So I just want to point out something. You see how similar these two formulas look? This one, the only difference is where's the minus sign, right? Please do not attempt to learn this the day before or hour before the exam. All these formulas look so similar. Cramming it is not going to work, right? All right, so let's try a different question now, right? Let's say, I see a lot of students, let's do a reflection in the y equal to x, okay? Y equals to x. So we want to reflect ABC, which is this triangle, in the line y equal to x. All right, so let's see how this goes. y equals to x. And remember, they wanted to do it on the original triangle. They did not say a dash, b dash, or c dash. So let me just kind of clean up here a little bit. Right? All right. So I should probably move this to make space. All right. Right. Remember, you can press L to speed it up if you wish. I'm gonna try to do all the work in one time for you. Right, to save some time. All right. So we want to reflect this in the line y equals to x. All right. So what is the formula for the reflection in the y equal to x? Is 0, 1, 1, 0. 0, 1, 1, 0. So I'm going to write it 0, 1, 1, 0, 0, 1, 1, 0. And what we are going to do, we're going to take this matrix and multiply it by A, and then we're going to take it and multiply by B, and then we're going to multiply by C. So this one is A, this one is B, this one is C. The answers we get now will not be A prime, because we already used A prime. It will be A double prime. So you have to put 2 slashes, and this one will be B double prime, and this one will be C double prime. So A is 1 minus 1, that's this. B is 1 minus 4, and C is 3 minus 4. So all we have to do is multiply this by this. So if we do that, I believe we will get, let's make sure I don't do it wrong, minus 1, 1. This one will be minus 4, 1. And this one will be minus 4, 3. All right, let's double check in my working. Yes, it's correct. So what I have to do now is draw these 3 points. A double prime is minus 1, 1. Minus 1, 1. That's A double prime. B double prime is minus 4, 1. Minus 4, positive 1. And C double prime is minus 4, positive 3. Right? All right. So this is the answer if this got reflected in the line y equal to x, right? I'm already supposed to put the points next to it, the minus 1, 4, but my diagram isn't so big and these markers are really fat. But in the exam, you make sure and put the coordinates next to it. All right, so I showed you how to use these 3 formulas, 2 and 3. Now, if it was a reflection in the line y equals to minus x, you would have just multiplied it by this one instead. So I'm just going to pause the video. I'm just going to cut this video short, and I'm going to come back in a few seconds to show you how to use the clockwise and anti-clockwise and enlargements. Hi, and welcome to the next part of the video. And today, I'm going to show you how to do rotations, the matrices method. All right, so here we have a question. They gave you a triangle A, B, C, and I put down all the coordinates next to the point. And here's what they want you to do. They want you to rotate this by 270 degrees. Now, whenever you're doing a rotation question, pay attention to which direction they want you to rotate it. It can either be clockwise or it could be anti-clockwise. Both formulas look almost the same, except for clockwise, this sign is minus, and for the anti-clockwise, this sign is minus. In this particular question, it's a clockwise rotation, which means it's this formula we're going to use with the minus sign here. So I already wrote the formula here, cos sine minus sine and cos theta. So what we need to do is take this formula and visit each point and multiply it by this formula. But there's a little problem. We need to simplify this formula first. So they told us to rotate it by 270 degrees, which means we need to replace all the thetas with 270 degrees first. Right? So replace all of them with 270. And all we need to do is just punch this in our calculator and we'll get a number. Punch this in our calculator and we'll get a number. And the same goes for the other two. So let's see what number we will get. So make sure my calculator is on the degrees mode. Cos 270, that's this guy, will give us 0. So cos 270 is 0. Let's try sine 270. That will give us minus 1. Minus sine 270 will give us positive 1. And cos 270, we know it's from 0 from this one. So the formula we are actually using, the matrices, sorry, will be 0, minus 1, 1, and 0. And we need to take this matrix and multiply by A, then by B, and then by C. So let me just lay it out. We have to take this matrix and multiply by A. A is minus 2, 1. We have to take this same matrix and multiply it by point B. And point B is minus 2, 6. C, well, the same matrix is 0, 1, minus 1, 0. And we have to multiply by C. And point C is, everybody mix up there, C is minus 5, 1. Right, now remember I told you I will not be reviewing how to actually multiply the matrices. But when we take this matrix and multiply by point A, I believe we will get minus 1 here and we will get minus 2, making this A prime. Take this matrix and multiply by B to get B prime, or the new B point. So that means we will get minus 6 here. Just double checking my answer, and minus 2. And when we take this matrix and multiply by C, we will get C prime. So that means we will get minus 1, 5. Okay? No, minus 1, that's not, double check it here. Minus 1, minus 5. Alright, so all we need to do now is plot these new points. We get a thinner marker here. Minus 1, minus 2. This is A dash. Now I'm supposed to put the actual coordinates next to it, but my diagrams are a little bit cluttered, and like I said, I'm using a very thick marker. B prime is minus 6, minus 2. B prime, you see there, minus 6 and minus 2 on the Y. And C prime is minus 1, minus 5. Right, let's connect this up. So, if we were to rotate this by 270 degrees clockwise, right? Which direction is clockwise, by the way? Clockwise is this way. If we were to rotate this by 270 degrees clockwise, it would end up here, right? I just want to prove to you that this answer is actually correct. You can actually do a test in the exam itself to make sure your answer is correct. So here's what you're going to do. In the original shape, which is the purple one, choose any point. It really doesn't matter. I'm just going to choose point A, right? What you need to do is take point A and connect it to the origin. So I took point A and I connected it to the origin. Once you reach the origin, connect it to its rotated point. Remember, A was moved from A to A dash. So connect it to A dash. This angle looks like 90 degrees, which means the other way around is 270 degrees. So it's actually a rotation of 270 degrees clockwise, or it's a anti-clockwise rotation of 90 degrees. Because think about it. If you rotate 270 degrees this way, you can achieve the same result by rotating 90 degrees the other way. Now let me just prove it with another point. Let's say we took point B. Take point B and connect it to the origin. Use an orange here. Once we reach the origin, connect it to its rotated point. You will notice that the orange angle also looks like 90 degrees. So if we go the other way, it will be 270 degrees. Of course, if it did the same thing for point C. So this is an actual way to prove to yourself that, hey, my answer is actually correct in the exam. So I just want to point out, when we're doing clockwise or anti-clockwise rotation, make sure you read the question properly so you will know which one to choose. If they told you to rotate it by 90 degrees, you will replace all the thetas with 90. If they told you to rotate it by 180 degrees, you're going to replace the thetas with 180. Now here's a common trick in the exam. Whenever they ask you to rotate it by 180 degrees, they will not specify whether it's anti-clockwise or clockwise. Because if you, let me prove this to you, that when it's 180 degrees, it doesn't matter if you pick the clockwise or the anti-clockwise formula. You will get the same answer. Let me prove this to you. This marker, if I ask you to rotate 180 degrees clockwise, you will end up here. If I ask you to rotate 180 degrees anti-clockwise, you will end up here. It doesn't matter. Right, so moral of the story, when it's 180 degrees, do not expect the examiner to tell you whether it's clockwise or anti-clockwise. Now, I don't want to make a separate video on how to do enlargements, but it's really simple. So I'm just going to clear it up here now one time. If somebody asks you to enlarge a shape by a factor of k, the formula is just k. This is 0, 0, k. If they tell you to make the object or to enlarge it by a factor of 2 or to make it twice as large, all you have to do is take the k's and replace it with 2. The zeros remain 0. And what you would do is take this matrix and multiply by all the points, and the answers you get when you plot it on a graph, the object will look twice as big. If they tell you to make it 3 times larger, you just replace the k's with 3. If they tell you to reduce it by a factor of 2, if they tell you to reduce it, notice I only gave you the enlargement matrix. But if they told you to reduce it by 2, all you have to do is replace the k with a half, not a 2. So if they told you to reduce it by 3, you would replace the k's with 1/3 and 1/3. Alright guys, so in my next video, I'm going to do combinational matrices. I'm going to show you how to do 2 things in one question rather than just an anti-clockwise by itself, rather than doing a reflection in the x-axis by itself. So, see you soon. Take care. Alright, good day and welcome to my next video on combining matrices. Alright, now to explain what this topic is about, that we have to go through a long process for me to actually tell you, to show you what is the use of this topic. So let's get started. First of all, on a piece of graph paper, I would really like you to draw this. A is -1, -1. B is -3, -1. And C is -1, -4. This is our original shape. Now, here's what I want you to do for this shape in part A. I want you to rotate it by 180 degrees. Now, you notice I said rotate. So when you are rotating, there are 2 ways you can rotate, clockwise or anti-clockwise. So which one am I talking about? I did not specify in the question. However, remember I told you previously, when it's 180 degrees, you can choose any one of them. So I'm going to speed up this process. So I'm just going to choose this one here, right? And since it's a rotation by 180, I have to replace all the thetas with 180. So let's do this quickly and see what four numbers we get. Cosine 180 is minus 1 minus sine 180. Right? So where was I? Sine 180 is 0, right? Now it's sine 180. Well, sine 180 I know for a fact will give me 0. You can try it on the calculator. And we know cos 180 is minus 1. So what we need to do now is take this matrix and visit points A, B, and C and multiply by this matrix. Now I kind of set it up beforehand. So this is how it will look. I took this matrix and I'm going to take this is this. Take this matrix and multiply by point A. That will give me the new point A prime, and then do the same thing for B and C. So let's get started. Point A is minus 1, minus 1. Point B is minus 3, minus 1. And point C is minus 1, minus 4. Right? So let's multiply these out. Now remember, you have to be a pro in multiplying matrices to get through this topic. So if you don't know how to multiply matrices, I'm reminding you again to go and watch the previous videos. So let's multiply this. Let's see what we get here. We'll get minus 1. We'll get positive 1 here. And positive 1. 1 and 1. This one here we will get positive 3 and positive 1. And this one seems to be positive 1 and positive 4. So let's waste no time and plot these new points. 1, 1. So it's a rotation by 180 degrees. So A dash will be here now, 1, 1. B dash, well, B prime is 3, 1. And C prime is 1, 4. And if we connect this up, sorry for my bent up lines, but this is the best I can do at this point in time. All right, so when we rotate this red triangle, the original AB by C, we get the green triangle. So we rotated it by 180 degrees. And once again, it doesn't matter if it's anti-clockwise or if it's clockwise. 180 degrees, you don't have to care whether it's clockwise or anti-clockwise. Now, in part B, they want you to reflect the shape A in part A. So that's the green shape they're talking about. They want you to reflect this new shape in the y-axis. So that means if we reflect this in the y-axis, it should end up on this side. But let's do all the calculations for it. What's the reflection for in the y-axis? We pull out my formula sheet here. Reflection in the y-axis, that's this guy here, minus 1, 0, 0, 1. And we have to take this matrix now, this blue matrix, and multiply all the new points, all the green points by the matrix. So I set it up beforehand again. That's this matrix there. I'm going to multiply by this one by A dash, by B dash, and by C dash. So let's get started here. I keep saying A dash, but I already know it's A prime. That's a habit I have in class. A dash is 1, 1, B dash is 3, 1, and C dash is 1, 4. Let's multiply this out. If we multiply this by this, we will get minus 1, 1. If we multiply this by this, we will get minus 3, 1. This by this is minus 1, 4. Great. Let's plot these new points. I'm going to put it in blue. A double dash is minus 1, 1. B double dash is minus 3, 1. C double dash is minus 1, 4. If we connect this up, it looks like a reflection in the y-axis. All right, now that's nothing new. I mean, we did stuff like this in the previous video. So what am I getting at? Let me explain what happened here. It was two things we actually did. First, we started off with this triangle and we rotated it by 180 degrees. And we ended up by the green triangle. Then we went from the green and we reflected that in the y-axis and we finally ended up where the blue triangle was. Now, how much sets of working did we have to do? Let me just put it in front of you. Didn't we do 2 sets of working? Didn't we multiply everyone by this matrix first? And then we multiplied everyone by this matrix. So it's 2 sets of working, and this is quite a lot of working. Read part C. They want you to create one matrix, not 2, one matrix that will map. Map just basically means you're going to start at which triangle? The normal ABC, that's the red one. And they want you to map it straight to A double dash, B double dash. That's the blue triangle. So they want you to go straight from the red to the blue. They want you to skip the middle step. In other words, they want you to create one matrix that will rotate and reflect in one shot. So to do that, we have to combine 2 matrices. And when you combine these 2 matrices, you get something, and I just call it this, a super matrix. And this super matrix will do 2 things in one shot. And I will prove it to you. However, there are some rules. When you are combining matrices, remember, there's 2 matrices, right? Combining matrices really means you're going to multiply the matrices. But when you multiply or combining matrices, do not multiply the first by the second. That's the wrong thing to do. In fact, you have to take the second matrix and multiply it by the first. You have to do it kind of wrong side. So what do I mean by the second and first? Well, according to the procedure we did here, didn't we rotate first? Wasn't this the matrix we used for the rotation, and we used this one first? Then, afterwards, secondly, we applied the reflection. This was the matrix responsible for the reflection, and we used him second, right? So when we are multiplying it, we have to put the second matrix first and the first matrix second. This is the correct way to do it, right? This one is wrong. So I kind of summarized it at the bottom here. I color coded to green and blue. Notice this is the second matrix, that's this one, and I put it here. And this is the first matrix, so I put it here, second here and the first here. And you have to multiply these 2 matrices. And these 2 matrices, when you multiply them, like I said, you will get a super matrix. You will get 4 numbers. And this super matrix will do 2 things. It will rotate and reflect. So, like I said, I'm not revising how to multiply matrices, so I'm letting you all know that if you multiply these 2 matrices, you will get 1, 0, 0, and -1. That is what you will get if you multiply these 2 matrices. Okay? Now, I have to prove to you that this pink matrix, this super matrix, which the examiner asked us to get, will go from here all the way to here in one shot. But remember this, second by the first. Please make a note of that in your books. So here's what we're going to do. We're going to take a test point. Let's take point C. I am going to take point C and multiply it by this matrix. So I'm going to put it here now. I'm going to take point C and C is how much? -1, 4, -4, -1, -4. And when we multiply these 2 matrices, it's supposed to go straight to C double dash. It's supposed to do this and this in one shot. And if you take this matrix and multiply by this matrix, you will get -1, 4. minus 1, 4 is C double dash. And you could try it for A. Take this matrix and multiply by A, and it will go straight to A double dash. And you can try the same thing for B. It does two things in one shot. It's like a time saver. Okay? Now, if the examiner asks you to describe, I've seen this happen in exams. If they ask you to describe the super matrix or the one matrix that they made you find, the answer, a lot of students are confused by the question. They're like, what do you mean describe it? It's two brackets, it has 4 numbers, it's pink. They don't want a physical description. You will notice that this matrix is actually what? Where is it? Oh, it's actually this matrix here. 1, 0, 0, minus 1. If they ask you to describe it, the answer for 1 mark, it's a reflection in the x-axis. Because you notice that what basically this is. If you take this triangle and reflect it in the x-axis, you will get the blue triangle. So anytime they ask you to describe a matrix, they're already asking what it does. Okay? Right. One more thing before we go. So this is the super matrix here, right? So understand what the super matrix does, okay? The super matrix goes from the red triangle all the way to the blue triangle. Suppose now, I'm going to make up a part D here for you all. Suppose in part D of the question, they ask you to create a matrix that will map, I'm just summarizing, map. See if you see this here. Sorry about this. Right. You notice this question and this question is the opposite. This question starts off with the red triangle and goes to the blue triangle. But part D is asking you to start off with the blue triangle and work your way backwards to the original red triangle. They're asking you to reverse the process. Anytime they ask you to reverse the process, that's code for inverse. They want you to find the inverse of the matrix. So this guy, the super matrix, he is responsible for this way. So the inverse of this matrix will reverse the process. So all we have to do is find the inverse of this matrix. To find the inverse is really, really simple. Right? Remember, you have to find the determinant and throw it underneath the 1. Let's find the determinant. 1 by minus 1 is minus 1. You must put a minus sign after, and 0 by 0 is 0. So minus 1 minus 0 is minus 1. So we end up with 1 divided by minus 1. Then we switch these two things here. We switch the leading diagonal, and the other diagonal, they just become the opposite. But the opposite of 0 is still what? 0. Okay? Now, you can simplify this. This is the inverse, by the way, but I believe that this could be simplified. If you simplify this, 1 divided by minus 1 is what? Minus 1. And then you have to multiply every one inside here by the number outside. Minus 1 by 1 is positive 1. Minus 1 by 0 is 0. Minus 1 by 0 is 0. And minus 1 by 1 is minus 1. So, it just so happens the inverse is the same thing as the super matrix. It won't always be like that. But this matrix would definitely reverse the process. If you took this matrix and multiplied it by C double dash, it would send you back to the original C point. Alright guys, I really hope that you understood this video. And of course, if you're from Trinidad and Tobago and you need lessons in almost any subject, I'm located in Cunupia. You can always call that number. Take care guys.